S. Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So we will continue with the same concept which we have discussed in part 1, that is change of order of integration. So we have already learned the strip method. So we will start with multiple integral. In this lines, we will first start with double integral. Welcome back to S. Chan Academy. So for the detailed syllabus covering, you can refer to this book from S. Chan Publishing. And if you don't have the hard copy, you can click on the link which is given in the description box. Now we will continue the same example. So this was the question which we were solving for after changing of order of integration. So as I told that this should be the intersection point. So this intersection point is 2 to 4, and that's how the limits for y will become 2 to 4. Now we will integrate it by using both the methods of taking the same region of integration, and then we will see that we will get the same result. So first we will take with the limits for a y first. So for the limits for y, if you can memorize, this was 4x plus 2 dx dy, and it was from x squared to x, and y was from 0 to 2. Okay. Now, we will, as I said in the earlier video, that these are the limits for y. Whenever they are given in terms of x, they should be the limit of y. So we need to integrate with respect to y first. Since there is no y in the integrand, so therefore we will be getting 4x plus 2y dx. And limits for y has been written as from x squared to x. So it becomes 0 to 2, 4x plus 2, and then x minus x squared. So the integrand is free of y now, and we can see that now we are left with the integrand which is purely in terms of x. So you can easily integrate that, and after integration of this, we will get some value. This I keep as an exercise for you, and I will tell you the final answer so that we can move to the next part. So for this, the answer needs to be 8. So we will take this region of the limits for the same region of integration, but like this. So your x is moving from y to under root y, and y is moving from 2 to 4. So we will compute the same integration by changing the limits. So the integration function is 4x plus 2, and this time we have the limits as for x, you can see that the limits for x are from y to under root y, and for y it is from 2 to 4. So we will be integrating by taking the same limits, y to under root y, and since they are the limits for y, they are the limits in terms of y, therefore it should be understood that they should be the limits for x, and limits for y are from 0 to 2. So the resultant will be integrated with respect to y. So when we will integrate it with respect to x, so y will be treated as constant. So our integrand is free of y, so it has got 2x squared plus 2x, and limits are being written as y and under root y dy. So when we will substitute these limits, our integrand will be free of y, and then we need to substitute, we need to integrate with respect to y, and then we will substitute the limit for y. So if we do this, so it becomes 2 of y minus y square and plus 2 under root y minus y. So you can integrate it easily because it has been turned into a single integration. So for single integration, it is very easy to handle. So you can integrate this and you will see that the final answer will be again remain same 8, which was when we have integrated with respect to y first and then with respect to x, and here we have integrated the same function with respect to x first after changing the limit of and after changing the order of integration from yx to xy, and the answer remains same for that. So that is the benefit of change of order of integration. That is the way of change of order of integration to be computed. Now we have taken, as I said that, in this question, this was a simple question of changing of order of integration. So in this one, we have not come across the benefit of change of order of integration. So if we take one more question where we will understand that if we take the limit for a y first and what happens, and if we take the limit for x first, what will happen. So we will take a different example. So this is next example. So in this one, as we will take the same sketch which we have discussed. So if this is your parabola, this is your line. Let me say that the line is y equal to x plus 2, and this is of course y equal to x square. So this is, and let us say that this is the region of integration. Okay. So you need to compute the integral. Compute I as this region of integration, and let us say that xy dx dy. Okay, so we will find out the limits in both the ways by taking with respect to x first and with respect to y first. So let me write it clearly. X square. Okay, so first we will compute the same integral by taking the limit of y first. So limit of y first, so we need to take a strip parallel to y axis. So if you look at the, let me change the color of the pen so that it is clearly visible. So if we are taking the strip here, so the lower end is lying on this parabola and upper end is lying on this line, and throughout this region the pattern remains same. So that is why we will take the limit of y. So the as I said, that limit of y will be taken as from bottom to top. So bottom is lying on this parabola. So y is going from x square to x plus 2. And the limit for x, we need to find out these intersection points. So you need to find out this point and this point, which will be deciding the lower limit and upper limit for x. So we need to find out these points. So limit for x are from -1 to 2, and this is xy. So since they are the limits for y, because they are given in terms of as a function of x, so it should be understood that they are the limits for y. So we need to integrate this function with respect to y first and then with respect to x, and therefore according to the standard notation, this should be written as dy dx. So we will integrate this integration. So it is 0 to 1. So this will be, first we are going to integrate with respect to y. So therefore this becomes, x will be treated as constant, so it is y square by 2, and it is from x square to x plus 2 and dx. So the resultant of this one will be free of y, and then it will be integrated with respect to x, so that we need to find out the result for that. So you can compute it quite easily. So it becomes -1 to 2 x, and this 2 can be taken out, and it becomes x plus 2 whole square minus x square dx. So this can be simplified quite easily. It is a very simple integral algebraic function in terms of x only, so it can be simplified quite easily. So the answer for this is 9/2. Now since we would like to change the order of integration, therefore now we would like to have a strip parallel to x-axis. So if we look at this one, the strip, if we take parallel to x-axis, and let me change the color of the pen so that it is clearly visible. Now the strip needs to be taken parallel to x-axis. So you can see that the lower end of the strip is lying on this line and upper end is lying on this parabola majorly. But if you look at the region below this point, and the strip is moving like this. So the lower end is lying on the parabola and upper end is also lying on the parabola, while as soon as it crosses this point, the lower end is lying on the line y equal to x plus 2 and upper end is lying on this parabola y equal to x square. So it is a clear indication that this whole region of integration needs to be divided into two parts. So let us say that this part is R1 and this portion is R2. Above this blue line it is R2, above this blue line, it is R1. And here we are going to use the property which have been told in the first lecture, that whenever R is formed as a union of non-overlapping regions R1 and R2, so then the integration needs to be written as a sum of those two parts. So for this one, the integration will be written as R1 fxy dx dy plus R2 fxy dx dy. So first we will find out the limit for this R1, limit of variables for R1, and then we will find out the limit for R2. So let us try to find out the limits for R1 first. So if in R1 you can see that lower end is lying in the second quadrant. So though it is on the parabola, so though it is y equal to x square. So x is moving, I will write here itself so that we don't have to move again and again. So for this one, so now we need to take this as x is going from what to what. So x is going from minus under root y to plus under root y. So minus under root y to plus under root y. Okay, and this point is R equals, this point is, we need to for this y, we need to have this point. So this point is 1. So lower end of the strip is on the line y equal to 0 and upper end of the strip in this portion is at y equals to 1. So the limit for y are from 0 to 1. So they will be the limits for x and y in the region of integration as R1. Then we will write down the limits for R2. Now for R2, the strip is moving from this end, from this portion to this portion. So we need to find out that here, after this, the lower end of the strip is lying on the line. So the lower end is lying on the line y equal to x plus 2. So if we write x in terms of y, so x becomes y minus 2. So it becomes, it varies from y minus 2 to, and then it is upper end is lying on the parabola, that too in the first quadrant. So therefore we are going to take it as under root y with positive sign. Now for limit for y, they also do get changed. Now this was the point y equals to 1 and we need to find out that what is this point. So this point is y equals to 4. So y is moving from 1 to 4. Okay, so that's how the limits for R1 and R2 will be found out. For in this one, x is moving from minus under root y to plus under root y from second quadrant to first quadrant, and then as soon as it crosses this point, the lower end of the strip is lying on this y equals to x plus 2 line and upper end is lying on the parabola y equal to x square. That too will be only positive sign will be taken because it is lying in the first quadrant. So that's how the limit for both the variables will be written in both the regions. So that's how we will be changing the order of integration. So for R1 we have written the limits here, and for R2 we have written the limits here, and therefore this I can be calculated as, we will be writing down the limits for x here from minus y to y, and y is from 0 to 1, and the function is given as fxy dx dy plus. Then for R2, limits for y, for x has been written as y minus 2, and it is under root y, and y is taken as from 1 to 4, which is for the function fxy dx dy. So in this one we are integrating with respect to x first and then with respect to y. So since we are taking the same question, so we can see that what fxy has been taken. So fxy has been taken as xy. Now we need to substitute the function as xy. So it is minus y to minus under root y to plus under root y, and it is 0 to 1, and it is xy, and this will be written as dx dy only, because we are going to integrate with respect to x first and then with respect to y. And then here it is 1 to 4, and it is y minus 2 to under root y, and it is xy dx dy. So that's how you can see that, but the disadvantage is that now instead of one integral we need to solve two integrals. So suppose the same question would have been given in this way, then by changing the order of integration we would have converted these two integrals into one integral. That is, if we take the limit with respect to y first, then these two regions of integration will be merged into one region of integration, and only one integral will be doing our work. So here we need to integrate two integrals. So if you will integrate these two integrals, we are going to get the same results. So here we are going, as it has been discussed quite a few times, then that these are the limits for y, therefore they are the limits for x, since they are in terms of y. So we need to integrate with respect to x first. So it is going to be x square by 2, and the limits will be written as minus under root y to plus under root y, y dy, and then plus 1 to 4, and it is y minus 2 to under root y, and it is, so it is 1 to 4 and x square by 2, and here limits are from y minus 2 to under root y, okay, and then it is dy. So we will be left with y. So we can see that here the integrand will be converted into y, and here also the integrand will be converted into y, and limits for y has already been taken as constant, so we are going to get a constant answer. So if we will integrate this, since it is a single integration, so we can integrate it quite easily. So if we'll integrate that, we'll come out with the same answer, that is 9 by 2, which was there in which was same when we have integrated with respect to y first. So that's how we have learned that after changing of order of integration, if two regions of integration have been there, if we change the order of integration, then they could have been merged into one integral, and it will be reducing our work, it will be reducing our computation, and it is going to take less time in solving such questions. So that's how changing of order of integration is very, very important. It can lessen our work in sometimes what happens that in even 4 or 5 region of integration gets converted into one region of integration. So in solving 4 or 5 integration, we are going to take more time. In calculating one integration, we are going to take less time. So that's why changing of order of integration is extremely important. So I hope that the method, strip method, would have made it more clear in deciding the lower limit and the upper limit for both the variables x and y. So I hope you might have liked the method of for the strip method, by which changing of order of integration has become very simple, and I'm sure that if you'll practice it, then definitely you will find it very convenient in deciding the limits for both the variables x and y when even more region of integrations are there. For more details, please refer to the book from S. Chand Publishing, the details of which are given here, and link is also given in the description box, so you can download it. So if you have liked the video, please like, share and subscribe. Please press the bell icon in the given below so that you will get the notification as and when next video will be uploaded. Thank you very much.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.